Hello future engineers, welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends. That's one way you can keep me going, inspired and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Level 20, the coefficient of rolling resistance between the 30 kilogram lone roller and the ground is mu sub r point 0.1. Determine the force P required to pull the ruler at a constant speed. Then letter B, what force P would be needed to push the ruler at a constant speed. So the principle is we just locate point B where the reaction on the ground and the wheel, rim of the wheel or outer surface of the wheel meet or coincide. Then from there we sum up moments about that point so that we don't need to memorize formulas. We simply sum up moments about that point where the resultant on the ground intersects with the outer surface of the wheel, and the horizontal distance rather between the vertical line through the center of the wheel and that point where the resultant acts is the coefficient of rolling resistance. So for the solution, let's have R here, which is at point B. This is the anticipated location of the point where the resultant force on the ground acts. Then this is P sub R, and this is the coefficient of rolling resistance. This force, downward force, the net downward force is 30 kilogram times 9.81 minus the vertical component of P because it is upward, which is P sine 30. So that's 30 times 9.81 minus P sine 30 degrees. And the horizontal component of force acting at the center of the wheel that rolls or pulls the wheel rightward is P cosine of 30 degrees as shown in the figure. Then we will compute this exactly or approximately. The moment arm of P cosine 30 is radius times cosine of this angle of friction here, but we can actually estimate it or we can approximate it as simply the radius of the wheel, but in this problem we'll just compute it accurately, and it is r cosine of the angle of friction here, which is P sub r. So tangent of P sub r is 0.1 and it is equal to B over radius of wheel 150. So tangent of P sub r is 0.1 and it is B over 150 mm. So P sub r in degrees is 5.7106 degrees and B is 0.1 times 150, so it is 15 mm. We then sum up moments about P equals 0. So 30 times 9.81 minus P sine 30 degrees times B, which is 15 mm, equals P cosine 30 degrees times 150 cosine of P sub r. Or we can just approximate this as 150. But as mentioned earlier, we will solve this accurately. So solving for P is equal to 32.28 newtons. Then for the second part, uh, the force P that would be needed to push the ruler at a constant speed. So if the wheel is or the ruler is pushed, so this is the direction, and the vertical force acting at the center would now be 30 times 9.81 plus P sine 30 degrees. The horizontal component is still P cosine of 30 degrees, and this is still the point where R acts, but the force P should be applied up, down to the right, so that we satisfy the condition that we push this ruler. So 30 times 9.31 plus P sine 30 degrees times B, which is 15, equals P cosine 30 degrees times quantity 150 cosine of 5.7106 degrees. So solving for P for the second equation, P is equal to 36.26 newtons. Level 21, determine the horizontal force required to move a 2,500 pound automobile with 23-inch diameter tires along a horizontal road at a constant speed. Neglect all forms of friction except rolling resistance and assume the coefficient of rolling resistance to be 0.05 inch. So let's have the solution and let's have our guide to set up the equation. So the principle is we simply sum up moments about point B. This is the established equation and this is the guide figure. This is point B where the reaction between the ground and the wheel meet, and if the net downward vertical force is denoted by W, and this is the horizontal force that is required to roll the wheel, then we sum up moment about B, that's the principle, then W times B equals P times radius. So we just treat this moment arm of B to be radius approximately. So this is an approximate solution, and because the coefficient of rolling resistance is very small compared to the radius, should you compute this angle here, then you can, then the moment arm of B would be P would be R times cosine of this angle. But I but if you compute that, you will have almost the same results. So let's just use this as our guide. Then the W is 2,500, B is zero point zero 0.05 inch, then P is the required force, then the radius is 11.5 inch. Substitute, so 2,500 times zero point zero 0.05 equals P times 11.5 inches. Solving for P is equal to 10.87 pounds. Level 22, the wagon together with the load weighs 150 pounds. If the coefficient of rolling resistance is B equals 0.03 inch, determine the vertical force P required to pull the wagon with constant velocity. Here is the given figure. The coefficient of rolling resistance is 0.03 compared to the radius 3 inches. So the angle, if we compute the angle of friction, it will be very, very small that we can resort to approximate solution, which is acceptable in this case because the coefficient of resistance compared to the radius is very small. If you want the accurate calculations, then you can, but the answer would be almost the same. So for the solution, let's have our guide. The principle is we just sum up moments about B. So it is W times B equals P times approximately R. But the exact or accurate solution is R cosine of this angle. And as I said, this angle is very small. Inverse sine of 0.03, sorry, inverse tangent of 0.03 divided by radius. So that would be very, very small. So this W here is 150, but because there is a vertical component, upward vertical component of B, which is P sine of 40 degrees. The principle is we don't memorize the formula WB equals P times R for other cases where there are changes. Like for instance, in this problem here, there is vertical component. The principle really is, without memorizing the formula, is to locate that point B, and then we sum up moments about P. So this is the guide formula, but we simply sum up moments about B, where the vertical component, downward vertical component, is the 150 pounds minus P sine of 45 degrees, as shown in this free body diagram. This is R, and that's point B. This is B, which is 0.03 inch, and we just approximate P cosine of 45, the horizontal force, horizontal component of B. Then the moment arm, we just call it radius because as mentioned earlier, this angle of friction is very small. So 150 minus P sine 45 times B, which is 0.03, equals P cosine 45 degrees times radius, which is 3 inches. So only P is the unknown in this problem. Solving for P is equal to 2.100 pounds.